Good day everyone. Here you have the problem solver and I'm here in this channel to solve problems. So not all the problems that you can face in your life, but in the interview problems that you can face in big companies. Big companies like Google, Amazon, Facebook, and so on, that they have a lot of coding interview problems, and I'm here in this channel to solve your problems and to practice you on how to solve those problems. And today in this video we are going to talk about a problem called deep clone linked list with a random pointer. And in this problem you can find it in LeetCode under name copy list with random pointer. You can check this problem later on and you can practice after the video on how to solve this problem, especially if you are not coding with Java, the programming language that I am going to use in my videos. So if you are not a Java coder, you can also practice yourself on how to solve this problem on your own with the different languages. So let's discuss what is the problem here. So the problem here is we need to clone a linked list, but this linked list has a special trick, which is a random pointer. So let's try to see how does it work. So imagine that we have a linked list. We have a node 1. Node 1 has a pointer next to node 2. Node 2 has a pointer next to node 3. So let's imagine that we have 3 nodes only in our linked list. And this is a normal linked list, which is a single linked list. Each node has a pointer next to the next node and it has a value inside. This value could be a number, could be a string or whatever. So in our case we have a value, the value is integer, and we have a next pointer to the next one, and the third node here, it doesn't point to anything else. So this is the end of our linked list. And the special trick here in our problem that each node in this list has a random pointer to a random node in the list, which could be anything. So let's imagine that the node 1 has a random pointer to node 3, and node 2 has a random pointer to node 1, and node 3 has a random pointer to node 3 itself. So if we are trying to copy this list in a normal way, so we can think about the normal way how we can solve this problem. So if it is a normal linked list, we can say, okay, I will have the first node and create a node called 1, and next will be null. Then we go to the next one here and there and see, okay, so node 1 has a next node which is 2, so I create node 2. But how can I create node 3 and I don't know in which order will be node 3 in the list? So I have to keep the order of the list here, and also I keep the random pointers in its places. I want you to think about how we can solve deep cloning a linked list with a random pointer, and you can pause the video for a few seconds or few minutes to think how we can solve this, and let's come back again in a few seconds. Okay, so now we are back. So let's try to think how we can solve this problem and how we can keep the random pointer in the right place. So in our case here we have node 1 as next pointer to node 2, and node 2 has a next pointer to node 3, and node 1 has a random pointer to node 3 to pointer 2 has a random pointer to node 1, and 3 has a random pointer to itself. So let's try to think about how we can solve this problem in the brute force way. So let's try to solve it. So I will not write the code here, but I want you to like imagine how we can write a code for the brute force solution, and then we can talk about the optimized solution. So the brute force solution we can have like two iterations. The first iteration is to copy the linked list with the next pointer without think about the random pointer. So let's try to solve this. So in our case we should have like a pointer here and a pointer there to keep the heads with us. So I have this one. I create a new node 1. Then I move the next to this one. So I create a new node 2, and the next pointer of 1 will be 2, and so on and so on. So we create node 3. This is a simple way that we move our cursor from node to other one, and we create a new node and we point the next of the previous to our new node. So this is the normal way. Now we need to think about how we solve the random pointer. So the random pointer here is pointing to any node in the list, and we don't know what will be the order. So one way to solve this, we can start from the head. So we have the cursor here on node 1, and we want to see what is the random pointer. So we can count. For example, we start from the head, so the random pointer of 1 will be 1, 2, 3. So after 3 nodes, it will be like 3. So after 3 nodes, we can find the random pointer of node 1. So we can go here and okay, we start from node 1, and the random will be after 3 nodes from the head. So head is pointing to this one, no, okay, so it will be like this. And then we go to node 2. Node 2, the random pointer is from the head is 1 node. So we start again here and we see, okay, so node 2 will be here, and node 3 is pointing to itself, so it will be like this. So let's imagine what will be the big O notation of the complexity of our algorithm here. So the big O notation will be big O of n squared, right? So we have here two loops. The first loop will start to copy all the nodes of our list with the next point, and the next loop, then in the next iteration, it will be two loops inside each other that will search for what will be the next node, what will be the random node of our nodes. And we have to track how many nodes from the head for each node to find the random pointer. So the complexity here will be big O of n squared. But can we solve it in a better solution? Can we have an optimized solution for our problem or not? I want you also to think about this, and you may pause the video if you can think about a good way or a proper way to solve the problem. So after we think about how we can solve our problem in a less complexity, less than n squared complexity, I want you also like to think, can we solve our problem using some data structure? I want you to keep this question in your head all the time when you are going to solve a problem in your interview. You have to think, can we have any supportive data structure to help us solve our problem or not? This could help you a lot to have a less complexity in time and memory sometimes in solving a problem. So here we can have overhead of memory, but we will have a less complexity in time, of course. So let me erase this list and we start from scratch. So now we have the node 1 is pointing to node 2, node 2 to point to node 3, and node 1 has a random pointer to 3, 2 to 1, and 3 to itself. So what if we can have a unique identifier for each node? So every node we create, we have this unique identifier to keep with us. So the first iteration, we will copy all the nodes with next, but in the next iteration, we don't have to search for each node. We can have a unique identifier to tell us where will be the random node of our node. So let's try to think about this. So let's imagine that we have a unique identifier for node 1, which is 1, node 2 is 2, and node 3 is 3, and we copy the list like this, 1. So the first iteration will be the same like the brute force solution. Okay, so I created the 3 nodes here, and if we have a unique identifier for each node, so node 1 has a random pointer to node 3. So if I have this list, if I have the unique identifier of my new list as well, so 1 is 1, 2 is 2, and 3 is 3. So I know that node 1 has a random pointer to node 3, and I have 1 as a random pointer to node 3 here. So I can have a link to my random pointer to the correct node. So what is our unique identifier here? So if we think that we have the addresses, we have the memory address of each node is my unique identifier, so I can have a map that is mapping for each node we have in the old list to the new address of our new nodes in the new list. So if we have this map that is copying the address of each node in the old list to the new ones, that will help us to solve the problem with less complexity. So let's try to code this together and we can see how it works. So I'm using here Visual Studio Code, and in this problem I have the data structure of my linked list, which is node, and this node has 3 properties. The first one is value, which is integer, and I have 2 nodes. The first one is next and the other one is random. So sometimes in the interview questions they ask you what will be the list look like. You need to think about this. You need to think how the list will be like. So we have a node, and this node has some pointers to the next ones. So the signature here of my list will be copy random list. The method will be copy random list, and it is having a node in a parameter and it is returning a node. So we don't have like a full list of my linked list, but I have a node and I have a return a new node of my new list. And the node here is the head of my list. So if I have the head of my list, I can go through the whole list. And the same should be for the new list. So the first thing that I want to start with the corner case, that you have to think all the time about corner cases. So what if my head node is null? Then we don't have a list and we have to return null in that case. So if head equal null, I will return null. Okay, so this is basically the corner case of having no list. And then we can start. So first I want to have a copy of my head. So I call it node equal new node. And this node.value will be head.value. So I copy the head of old list, and I will not start with the next now. So here I copy only the value of my head node to a new node, and this node it will be my cursor to the next nodes. And I have to keep a copy of this one, which is node new head equal node. So I have a copy now of the new head and node old head, which is head. So I have to keep copies of my list So when I go through the list, I have to start with a cursor, and this cursor is moving from node to node, and I have to keep a copy from them so I can return at the end the new head. So at the end I want to return the new head, which will represent my new list, the deep clone of my list. So now we thought about, okay, we can have a map that will map the old nodes to the new ones, and we copy the memory addresses of the old ones to the new ones, which is our unique identifiers by default. So map of node will be named node to node equal new hash map. So I initialized my map, and the first element in this map will be node to node dot put the head and node. So it is basically here, the node is the first cursor of my first node of the old one, and the node which is I just created now to the new copy of my head. And then we start to loop over the list to copy the whole list with next pointer, and then we start to iterate again over the list to have the random pointer. So let's start. So while head.next not equal null. So now we have head.next not equal null. So if it is only one node, so it will not go here. But if we have more nodes in the list, more than the head, more than one node, it will continue. So node.next equal new node. So I created a new node because we have a new node. They are not only one node. So node.next, which is my cursor for the new list, will create a new node, and node.next.val equal head.next.val. So I copied the value, and I will put those in my map. So node to node dot put, we have the key will be head.next, the old one, and the new one will be node.next. And here we copied already the next, so the next pointer. So the next pointer here to my node will be, I created like node.next equal new node. So I copied the value, I copied the next pointer, and I put them in my hash map. Then I move the cursor to the next node, head equal head.next. This is the cursor of the old list, and node equal node.next. So I moved the pulse cursor, and after having a complete loop over this list, so I have a deep clone copy of my list, but without the random nodes. So now we finished the first iteration. The second iteration will be, okay, we need to copy the random nodes, and we have already a hash map that is mapping between the old ones and new ones, and simply we can get all the new nodes, all the new random nodes based on the old random nodes in the map. So I will start the cursor from the beginning. So I have node equal new head. So that's why I have the new head of my list. So I start the cursor from the beginning, and here while old head dot next, sorry, old node not equal null. So node.random. So here this node.random for my new list will be node to node.get the random pointer of my old head. old head dot random. This is simply how we can retrieve them. Then we move the cursor of the two heads to the next one. So old head equal old head dot next, and node equal node dot next. And at the end we return the whole list. So if we go through this code, we can see that in the first iteration we go through the whole list and we copy the value, we copy the next pointer, and we put them in our hash map, and then we move our cursor to the next node, and so on until we finish the whole list. And in the second iteration will be very simple, that for each new random node, it is one of the nodes we have in our hash map. And basically we use our cursor of random to get the new representative of our new node, of my random node. And at the end we return the cursor of our head of the new node. And you can try this, you can copy this code and try it on LeetCode, and you can see how does it work, and does it solve all the cases or not. Do we have any corner cases that I didn't solve or not? You can also check all of this, and you can write me if you have some enhancements of my code. We can think about some more optimization we have of this code. So at the end here we have for the code a big O of n, so because we have only one loop and this loop doesn't do any other loops inside, and the same for the second one. So the whole thing that in our code is big O of n, and we solved the problem in a less complexity of time, but we added a more complexity of memory. So we have a hash map of n square. So this is our memory complexity for this problem. So I hope you enjoyed my video here today, and please hit like, share and subscribe if you liked the video, and you can write me some comments for some problems that you want me to solve for you. And yeah, I hope you have a good day everyone, and I hope also to have a happy coding and happy problem solving at the end. And see you next video. Bye.